All right, this will probably, I don't know. Yeah, we'll probably fit another test in. So this will be the first test of the, does everybody listen now? This will be the first test of the fourth marking period. Now, I haven't completely looked ahead, but I would say my guess is we'll probably only have 2 tests. My guess is. We might be able to squeeze in 3, but my guess is we'll probably only have 2 tests and just, maybe a handful of homeworks, maybe 2 handfuls of homeworks altogether. So like I said earlier, everything counts. All right. I'm just gonna do some problems for you. This is a front and a back. There's 26 problems on this worksheet. I'll do maybe 3 or 4 for you. Okay, so that's what we're doing right now. So radical equations. When you see the word radical in math, what are we talking about? Square roots. Okay, it's not just square roots, but yeah, that's a big thing. To tell you the truth, on this worksheet, everything is just a square root. Okay, so that's true. But any kind of a radical, that right there, that thing right there, that crazy looking check mark looking thing, that's called a radical, right? It could be a square root, it could be a cube root, fourth root, fifth root, and so on, but that's a radical. So what does that mean? Well, let's talk about that. So what if I said, if you don't see any number, I was going to say something, but it probably would have come out mean, so I'm not going to say it.
You deserve it. Whatever you want to say.
What if you had this? This is called the square root of 9. What are you asking yourself when you say the square root of 9? Yeah, what number, times itself. It's not just, because some people would say this. I've heard many students say this. Oh, what 2 numbers multiply to be 9? Well, that's only like a half truth, isn't it? Okay, there are 2 numbers that multiply to be 9, but you want to find the 2 numbers that are exactly the same, all right? So what 2 numbers that are exactly the same multiply to be 9? 3, yeah. We're not even going to do the plus or minus. That is true, all right? And that's a little bit more advanced. We kind of did that when we did the regular book stuff. But for this worksheet, I believe, I'm almost positive, they're not going to use the plus and the minus. They're just going to use the positive version of it, okay? Everybody with me on that? Yeah. All right, so we won't worry about the negative part. We'll just worry about that. So what if you had something like this, though? What if I said the square root of x equals 3? Now, I made this super easy because you kind of see right above it what this should be. But I want you to just think about what we're doing here. So what does this mean? It means if I take the square root of some number, my answer is going to be 3. So what number am I going to take the square root of in order to get a 3 for an answer? 9. A 9, right, because it's right there. It's right in front of us, okay? Everybody see that? That's what it's asking. So instead of just sitting there and just looking at it and saying, I wonder what number, if I take the square root of it, am I going to get 3? I mean, I guess you could do that, but it's not always going to be quite that easy. What's a mathematical way, instead of just looking at it and thinking what that number should be, in order to get x by itself? Nisi? That's it. Okay, I want to get rid of that square root. Okay, I want to get x by itself, right? We've been doing that in the last couple worksheets, getting x by itself, solving for x. But I want to get rid of the thing that's with the x. What's the thing that's doing something to the x? It's that square root, that radical. That's right. Okay, so how do I get rid of it? I do the opposite. Remember that? We always do the opposite to get rid of something. So what's the opposite of square rooting something? Squaring it. That's right. So I'm going to get rid of that square root by squaring it. So I'm going to square that side. And like we said dozens and dozens of times in here, if I do something to the left side, what? I've got to do it to the right side. So if I square the left side, I come over here and I square the right side. So what happens to that square and that square root? What do they do to each other? They cancel each other out, right? That's the whole reason why I squared it. You understand? The whole reason why I squared it is so that the square root would go away and would cancel out. All right, so that cancels with that. What am I left with over here? Just an x, and now I can do my math here. What's 3 squared? It's 9. Is that what we said it should be? Absolutely, because the square root of 9 is equal to 3, so that would be my answer. And again, yeah, we're not going to. Enough of that. Okay, everybody good with that?
Mm-hmm.
All right, let's do another one. That was number 1. That right here. So that was number 1 on the worksheet. So I've done one for you. I'll do another one for you. Let's do number 3. Looks a little different, but the idea is the same. The idea is exactly the same. It's just one little extra step. It's not that big of a deal. Now, you could sit there and think, oh, if I take the square root of something, I'm going to get 3. Well, we already talked about this. So what should be inside that big old square root? A 9, right? Okay, but it's not 9 minus 4. That whole thing has to be a 9. So what do you think the x is going to be? What do I take away from... If I take 4 away from this certain number, I'm going to get a 9. What's that? Yeah, I've already explained that. But thanks for paying attention. Anyway, forget what I was going to say, because I think I'm going to confuse you. Let's just make it as easy as we possibly can. All right, so I want to get rid of the square root. How do I get rid of a square root? What did I do over here? I squared it, right? So I square that, and I square this. Now look what happens. That square and that square root cancel out. So what am I left with? Just an x? It's an x minus 4. I got to drop that whole thing down. So it's a little bit different, not much. It's actually just as easy, almost. And now I got this. And now I don't have any square roots. So that makes life a lot easier, doesn't it? Absolutely. Okay, I would rather not have square roots if I didn't have to have them, all right? So that's why we got rid of it. So now we do one little simple step that we've talked about before. We have to get rid of this minus 4. And then we add a 4. That's right. So how do we get rid of a minus 4? We do the opposite, which is adding a 4. So I come over here, and I do that to both sides. So that minus 4 plus 4 adds up to 0, which cancels out. And it's x equals 9 plus 4 is 13. So that should be the answer. We could always check to see if it works, right? Let's put it back to the original problem. Put a 13 in for this x. What's 13 minus 4? That's 9. What's the square root of 9? It's 3. Does it work? Yeah, it does. So that's always nice. You don't have to do it. But if you have time, right, if you've taken a test or something like that, if you got a lot of time, instead of turning it in 10 minutes early, okay, go through it, take your answers, plug them back in, and see if they really work. If they don't work, you either checked it wrong, which could be a possibility. That's when I was a kid, I was like, well, what's the use of checking it? Because I could always make a mistake by checking it, couldn't I? All right, so, there's that. But you could double check it, I guess. But it is helpful. It really is helpful. Just to plug it back in, make sure it works. Because if it doesn't work, you might go through here and be like, oh, man, I can't believe I did that. I subtracted a 4 instead of added a 4 or whatever. Okay? So I think it is important to check. Let's do one.
Mr. Rao?
Yes,
Can you send Byron a bill to the office, please?
yes,
Thank you.
you're welcome.
Tell us how it goes. You don't need what you got.
All right, let's do this one. We'll do a couple more. Ready? Let's do number 9. You're writing this down, right? All right, here we go. Solve. I didn't say that at the beginning. I just kind of assumed that you knew what we're trying to do here. We're trying to solve for the variable. Nah, it didn't. It's a good call. Did you hear what she said? She said, Nesia said, let's get rid of the negative 8 first. That's super, super important that you do that. All right? You're kind of in a groove now. We've done a couple already where you just squared both sides, right? But you're not going to square both sides because if you did, don't write this down, okay? But if you did square both sides, this is what you would have to do. You would have to square that whole thing. Then you got to do FOIL method. Now, you could do it. It would work, but it would be horrible, okay? I would not do it that way. That would be terrible. But you could do it. It would work. We're not going to do it that way. Right? As soon as you hear a math teacher saying that would be horrible, do you want to do it that way? No, of course not. All right? You want to do it the easiest way possible. Myself included. All right? I'm not just saying that for your sake, myself included. I want to do things the easiest way I possibly can. So the easiest way to solve this is to get rid of what's being added or subtracted to that square root first. Okay? So what's on the outside of that square root? Get rid of that stuff first. All right, so what are we going to get rid of? What's on the outside of this square root?
-8.
The -8. How do we get rid of a -8?
You gotta add it.
Right. You're going to add it. All right, so that'll add up to 0. Now, if you do that to this side, that side, you got to come over here and do it to the other side. Now let's bring everything down. What happens here? Cancel out. What do we have left?
5a minus 5.
Well, it's the square root of 5a minus 5. That's really important. Equals -3 plus 8 is +5. Now we can do what we just finished doing, right? So really, was this any more difficult? It was one extra step, but it wasn't a difficult step. It was an easy step, right? So I wouldn't call it more difficult, even though you do have to do an extra step. And now what can we do? Now we can get rid of the square root because nothing's being multiplied by it, nothing's being added, nothing's being subtracted to the square root. Now there's stuff inside the square root that's being multiplied and subtracted, correct? But outside the square root, there's nothing else on that left side nothing else is doing anything to that square root, okay? So now I can get rid of the square root. So I square this side, I square this side. The square gets rid of the square root, so I just have 5a minus 5. And this, 5 squared is just 25. And now the rest is a piece of cake, right? We can do this pretty quick, can't we? Add a 5 to both sides. 5's add up to 0, cancel out, bring down the 5a. This is 30. Yep, divide by 5. A is 6. And there you go. And that's your answer. You could do what? Check it. Let's do it real quick. Let's do it in our head. 5 times 6 is 30. 30 minus 5 is 25. What's the square root of 25? 5. What's -8 plus 5? -3. Does it work? Guys, you should be able to do -8 plus 5 in your head. It's not tricky. It's 8 minus 5. 8 minus 5. That's tricky? Come on. All right. You guys are scaring me to death. All right. Let's do another one. Am I all right? I'm fine. Let's see. Yeah, let's do this one. Let's do 18. Now this looks a little different. Why does this look different compared to what we've done before? Fraction, okay, but also there's something else. Double square roots, okay? There's square roots on both sides, which actually makes this really kind of easy, to tell you the truth. Exactly right, okay? So it looks more complicated because you got 2 square roots instead of just 1. But if you look at this, how do I get rid of that square root? I square it, and that'll get rid of it. So what do I do to the other side? Square that. So that and that cancel. That and that cancel. All right, so now what do I do? 2n minus 88 equals n over 6. Yeah, what don't we like about it now? The fraction. That's not tricky. It's super easy. Super easy. And I'm not just saying that because I'm a math teacher, but actually I will have to pull out a calculator for a little bit of this. Get my calculator ready. Okay, it's all ready. So here we go. How do I get rid of that 6 right there? What's that 6 doing to that n? It's dividing, right? I know, but that wasn't the answer to my question. My question is, what is that 6 doing to the end? It's divided. So how do I get rid of something that's being divided? Now you can say it. I multiply. Now watch very carefully. Do I just multiply the 2n by 6? I got to multiply what? Everything. Everything. So I'm going to put it in parentheses. Yep. I'm going to put it in parentheses. So if I multiply the right side by 6, I have to multiply the whole left side by 6 as well. So really, getting rid of the fraction was not very difficult. You just multiply it by 6. It's not hard. Now what do we have here? Distributive property, right? I'm going to take that 6 and multiply it by both of these things right here. The first one's easy. 6 times 2 is 12n, right? Minus. Now, I don't know what that is. That's 6 times 88. That's 528. 528. And I use my calculator. I'm not ashamed to admit it, okay? To get 528. What's left over here on the on this side? The 6 is canceled, so what am I left with? Just an n. That's right. It's a 1n, but it's an n. Was that step hard? No. Because it had an n over here. You can't just forget about that, right? The 6 is canceled. What am I left with? An n. So I just drop that down. Now what I want to do is this. And we've done this on previous worksheets, right? Do you see how we've built up to this point? We've learned all these foundational things, and then we just start putting them all together, right? And that's what math is. If you can learn the foundation, and it's just one step, one step, one step, one step more, that's what math basically does. But you got to get on the ground floor. You know what I mean there? You got to be on the foundation. You got to know the foundational stuff, and then you can do this stuff right here. So I got to get n on the same side. So I could put the 12n on the right-hand side, but that would be silly. I wouldn't do that. So what would I do? I just said that would be silly to do that. So we're not going to do that. So I would get rid of the n. So I would subtract the n from this side, and then come over here and subtract an n from the other side. Why would I do that? Well, because I'm left with a positive 11n. I would rather have that, wouldn't you? You could also, in the same step, you could bring everything down if you wanted to, but I like to, in the same step, move this negative 528 to the other side. How would I do that? You would add it. That's right. So I'd add a 528, and then I'd add a 528 over here. Kind of did 2 steps in one. Is that all right? Well, you know that cancels out, so I'm done with that. Let's do this. I already said what this is going to be. It's 12n minus n, or 12n minus 1n, which is 11n. Thank you. All right. Equals. That canceled out. What am I left with here? 528. Does that go even? It does. Oh, I'll show you a cool way to multiply by 11. You ever see this? I'll show you in a second. At least with a two-digit number, it works out pretty easy. And I think there's a way to do it with a 3-digit. I just forget it. But the 2 digits are pretty easy to multiply by 11. So anyway, divide by 11. N is 48. What if I said, what is 32 times 11? You want to see the trick? Be ready to be astounded and amazed. Okay, so these are pretty easy when they add up to be a single digit. So watch, 32 times 11. I could put it in a calculator, it's fine, and I'll do it. I'll just see what it is. 32 times 11. I know what it's going to be. But anyway, so watch what you do. You take the 3 and the 2 and you split them. Put a little gap in between. Now, what goes in the gap? You're going to take that 3 and 2. Guess what you're going to do with that? You're going to add them together. So what's 3 plus 2? That is 32 times 11.
Holy moly! I just got amazed.
All right, see, told you. Give me another 2-digit number that when you add them up, it'll be a single digit though. 22. Okay, so 22 times 11. Oops. 22 times 11. So what do? You split them up. You add them up, and you get There it is. That's the answer. That's 22 times 11. I'll do it on my calculator and show Kyle. 242. See it? Kyle's not watching, but that's it. What if you had, give me another two-digit number. Okay, that's too easy. 71. What's 71 times 11 in your head?
711.
781. Good. All right. So you got a party trick now. Multiply by two-digit number by 11. What about 38? Now this is a little harder, okay? Because when you add these up, you get a two-digit number instead of a one-digit number, okay? But you can still, it'll still work. Watch. You got to do an extra step though. Whoops. You split up the 3 and the 8. You add them up. What do you get? You get 11, right? But so you put the 1 there and the 1 there. You got to add those up. So it's what? Why is my pen acting so weird? It's 4, 8. I don't think I'm pressing hard enough. So it'd be 418. There you go. So that's how you would do that. So when the digits add up to be a two-digit number, it's a little harder, but you just carry the number and all that. So there you go. Isn't that fun? All right. Let's do one more, and then we'll quit. Let me see. I don't know. Maybe we don't have to do one more because everything else, it looks... Oh, let's do this. Let's do this. We'll go backwards. What did I do? 18? Let's go back to do 14 now. This isn't much different, but it's a little different. So I think I will have covered every style of problem on this worksheet once we're done with this. Everybody look up here. It's not much different. It's the same idea as what we've done before. I'm going to solve for B. So everybody look. You trying it? Just making me do all the work? Do I square both sides to get rid of that square root? Not yet. Okay, because there's a number that's doing something to that square root that's outside the square root. Right, that -6 is being multiplied by that square root. So we need to get rid of that first. Before I get rid of the square root, let's get rid of the stuff that's doing something to the square root. In this case, we have something that's being multiplied. We had a case like that earlier, didn't we? Which one was it? This one? Yep. Look, this -8, right? This 8 was being subtracted from this. Would you agree? So we got rid of that first. This is kind of the same, except that -6 is not being added to this. What's it doing? It's multiplied. So how do we get rid of something that's being multiplied? Divide. So I take this whole thing, divide it by what? -6. Okay, you got to get rid of the negative as well, so make sure you divide by -6. So you come over here, you divide this by -6. The nice thing about these worksheets is they kind of rig these for you, and I believe, I don't have it, I can find it. Which one are we doing, 11? Uh-oh, where did I put it?
Your homework tonight?
No, I have the homeworks for you, but the answer key, oh, there it is. I'll put it in the back. Thought it was in the front. So let me see. I think every one of these come out to be an integer number. Yeah, so no fractions, no decimals. Everything comes out, not to be a whole number, because the whole number is 0 and all the positives. You will get some negatives. But it'll come out to a nice number, no fractions, decimals, okay? Now, life doesn't always work that way. When you're doing stuff in the field, math, it rarely comes out to a nice whole number. But in high school math, it happens a lot. So anyway, what happens here? That cancels with that. What happens here? What's negative over negative? Positive. What's 12 over 6? 2. And then this equals the square root of b plus 4. Now we can go back to what we did the first thing today. All right, because there's nothing else on the outside of that square root on the right side. So now I can not square root it. That's different. Okay, I know what you're thinking, but you got to say the right thing. We're not square rooting it, we are squaring it. So you square both sides. What do you get here? You get a 4. That thing cancels out here. You got a b plus 4. One more step to get the b by itself. Subtract a 4. So what's b equal to? 0. Right, because 4 minus 4 is 0. That's it. Let's check it, see if it works. Stick a 0 in there. 0 plus 4 is 4. What's the square root of 4? It's 2. What's 2 times negative 6? It's negative 12. It works. All right. So that's kind of cool. It's pretty much it. What do you think? You like this stuff? Yeah, so far so good, right? Now, this is, I didn't write it down here, but on your worksheet or your lesson plan thing, what does it say? It says radical equations, what, after it? Part 1. You're not looking at your paper? I gave it to you, right? Part 1. So, what's tomorrow? How about that? And what do you think? It's radical equations again, but what do you think we're going to do? We're going to get a little bit what? A little easier? Probably not. It'd be a little more challenging, all right? But, again, this is a foundational thing. Okay, get a good foundation under you, and then you can go up to the next step and do the next thing. So let's make sure we know how to do these, and make sure you work on them. Do not just write down the answers and turn them in, expect to get credit for it. Look at all the work that I showed just for that one. Okay? Look at all the work I showed for this one. All right, so if all you're doing is, here's number 9 on your worksheet, and you just put a 6. And then on number 10, you put a 3. And number 11, you put a negative 2. Because I read off all the answers, because that's what I'm going to do tomorrow, right? You know how this works now. I'll read off the answers to you. And I know for a fact, 100%, without any doubt in my mind, that many of you are just doing this. You're hearing the answers that I read off, and you're just writing them down, then turning it in. Okay? You're extremely lucky to even get 1 point. Okay? And I think I've been nicer than that. I think I've only been taken off -3. All right? I should take off what? -5. I should give you a 0. All right? If this is all you do, is just write down the answers when I read them off. Okay? I could have a kindergartner come in here and read off the answers, and they could put it down here. All right? You've got to show your work. And don't tell me you're doing this stuff in your head. All right? And if you do it on another sheet of paper, that's fine. I have no problem with that. But include that other sheet of paper and show your work. We good? All right. I'm telling you, I'm going to be really, really picky on showing your work. I don't look at your problems and see if you got them right or not. You know that, right? I've told you since day 1 I don't do that. But I do make sure that you know what the answers were supposed to be so that you know if you're getting them right or wrong or not. All right? Your homework is just a completion grade. It's just so that I know I give you some credit for doing the work. You've got to be checking to see if you're getting them right or not. Right? And just by putting down a bunch of answers, it's not helping you out. Especially now that I'm going to start giving out 0s instead of a 2 or a 3 for that. Right, got it? All right. Don't get mad at me when you see a 0. And you say, Mr. Hammer, I turned this into you. Well, you didn't do any work. We good? All right, enough of that.